For problem 2, I want to factor y is equal to x cubed minus x squared minus 4x plus 4. The thing that should immediately pop out to me is that there are 4 terms here. That's going to tell me that my factoring method is probably grouping. So if I see 4 terms and this is a higher degree polynomial, it's probably going to be grouping. The other reason I know I can use grouping here is because I can break these 4 terms down into 2 similar pairs. So I can break these 2 terms, these 4 terms into 2 similar pairs. And what makes these 2 pairs similar, I'm going to look at the variables that they have, and I'm going to look at the coefficients that they have. So first, looking at the variables, I have, here's my first pair, here's my second pair. The variables of the first pair are x cubed and x squared. And the variables of the second pair are x and, well, that's really x to the first power, and I have x to the 0th power here. And how do those pairs compare to each other? Well, what I notice is that I have x cubed and x squared and x to the first power and x to the 0th power. Those terms are 1 away from each other, or the powers are 1 away from each other. So the powers in each pair are 1 away from each other. Or rather, the second power is 1 less than the first power. I have x cubed and x squared, and I have x to the first power and x to the 0th power. The other similarity between these 2 groups is if I look at their coefficients, the other thing that makes up the terms. So if I look at their coefficients, I see of the first pair, I have a coefficient of 1. That's the first coefficient, and the second coefficient is -1. If I look at my second pair, the first coefficient is -4, and the second coefficient, which is technically a constant, is 4. So if I look at the coefficients, now again, remember this is technically x to the 0th power, so it is technically a coefficient. If I look at the coefficients, I can see that their absolute value is the same, but they're opposite signs in each pair. So I can also say that the second coefficient in each pair is -1 times the first coefficient in each pair. So if I take the first coefficient in each pair and multiply by -1, I get the second coefficient. And I have, in my first pair, a -1, and in my second pair, I have -4 and +4. All right, so I want to, because of these 2 similarities, I know that I can take out the GCF of both pairs and find a common factor between the 2 pairs. So for my first pair, I'm going to take out the GCF, and I know the GCF is x squared. I have x squared times x gives me x cubed, and x squared times -1 gives me -x squared. So that's how the first pair breaks down if I take out the GCF. Taking out the GCF of the second pair, I know this of the second pair, the greatest common factor is -4. I'm going to take out a -4. I know -4 times x gives me -4x, and -4 times -1 gives me +4. After I take out the GCF, I can see that these 2 pairs have a similar factor in common. They have x minus 1 in common. That x minus 1 comes from the similarities that we talked about. Looking at the variables, the powers being 1 away from each other, that's where that x comes from in my similar factor. Looking at the coefficients, if I take the first coefficient in each pair and multiply by a -1, I get the second coefficient. That's where that -1 comes from. So those similarities told me what the factor was going to be when I took out the GCF. Now, if I look at an example of what I can do, because these two pairs share a common factor, I can add them together. Just like if I had 4x plus 6x, like terms, I could add them together to get 10x. This is really saying I have 4 of x plus 6 of x. I have a total of 4 plus 6 of x. So just like I said there, what I can do in this example, I have x squared of x minus 1, and I have -4 of x minus 1. So I have a total of x squared minus 4 of x minus 1. And every time I say of, that means multiplication. I'm multiplying these two things together. This is factored form now. Two factors being multiplied together. That's my answer. Oh, I'm so sorry. Just kidding. I have to break this down further because it's the difference of two squares. So I actually have x plus 2 times x minus 2 times x minus 1. And that's my final answer.